Hi there, we're going to go over the solutions to the Unit 4.2, quiz number 2, all about volume. So we're going to start with number 1, which is asking for the volume of our cylinder. If you remember the volume of the cylinder, just found by finding the area of the base times the height. So the area of our base is a circle, so I'm going to do pi times my radius, which was 6 if the diameter is 12, squared, times the height, which was 10. So I'm just going to get 36 times 10, or 360 times pi. Run that through my calculator. I end up with 1,131.0 cubic units. On to number 2. Number 2, we have a net of a solid, and if we were to fold this up, we'd end up with a rectangular prism. And if you remember, that was just length times width times height. So you can see our length here is 9. Our height is 2. This was a little tricky. This from here to here was 7, but remember this matches here, so that's 2. So our width is really only 5. So to find the volume of this, I'm just going to do my length times my width times my height. 90 times 10, or 9 times 10 puts us at 90 cubic units. So that was just length times width times height. On to number 3. Number 3, we have a triangular prism here. And it does tell us our triangles are isosceles. So I've grabbed one of these bases so that I can find its area, because again, we still need the base times the height to find the volume. So we have a 25, 25, 14 if we drop the height. Remember, it does bisect the base, so this is now 7, and you'll recognize this is a 25, 7, and our height is 24 here, one of our Pythagorean triples. So back here, to find the area of my triangular base, I'm going to do 14 times 24 divided by 2, because it's a triangle, and the height of our prism is 30. So I can do some canceling, cancel out the 2 at the 30, multiply 14 times 24 times 15 on my calculator, and I end up with 5,040 cubic units. And we'll go on to number 4. Number 4, they've given us a pentagonal pyramid. If you recall, pyramids, their volume is 1/3 of the prism with the same base and height. So I'm going to do 1/3. They actually tell me my base area, so I don't have to do any work to find this. So 1/3 times 152, and our height is also given as 8. So we just had to multiply 152 times 8, divide by 3, whichever way you want to put that on your calculator. You end up with 405.3 cubic centimeters. For number 5, we're asked to find the volume of a cone. Again, a cone is also 1/3 of that base area times the height. For this one, they gave us a diameter was 3, so that means our radius here is going to be only 1.5. We will need the height of our cone. So I'm going to have to do, we're using a right triangle. If I double both of these, I get 5 here for the hypotenuse, 3 for this leg, which means this leg would be 4, but again, we don't have actual values here. We have half of those, so the height is only 2 on this. So I'm going to do 1/3. My circular base will be pi times 1.5 squared, multiplied by my height, which I found to be 2. So if I multiply 1/3 times pi times 1.5 squared on my calculator and double that, we end up at 4.7 cubic inches. For number 6. Number 6, it tells us we have a square pyramid, and they give us the diagonal length, which is 10. We also have the lateral edge, which is 13. So again, I'm going to do 1/3 times my base area times my height. So I have to find a couple of things here. Area of my base is a square, so these two sides are congruent. So we have a isosceles right triangle, or 45-45, and if your hypotenuse is 10, we can divide by radical 2 to get back here, so that would be 5 radical 2 for each of the side lengths. So for my area of my base, I'm going to do 5√2 squared, multiplied by itself, and I need that height. Again, if the diagonal is 5 from here to here, or the diagonal was 10, distance from here to here is 5, and hopefully you can see with your 13 and your 5, this leg must be 12, so our height is 12. So again, before I put this in my calculator, I'll do some simplifying. The 3 will cancel out here and make my 12 a 4. Remember, when you square, your 5 must get squared, so that's 25, and the square root of 2 gets squared, so that's a 2 times 4. So I have 25 times 8 basically, which brings me to a total volume of 200 cubic units. Number 7, we've got our spheres again with a radius of 3 compared to that of a radius of 6. This time we're looking at volumes though. If you recall, the volume formula for a sphere was 4/3 pi r cubed. Don't forget to cube that. So for our small sphere, I'm going to compare small to large in my ratio. The small sphere is going to be 4/3 times pi. My radius cubed, 3 cubed. 3 times 3 is 9, times the number 3 is a 27. For my larger sphere, still 4/3 times pi times my radius cubed. 6 times 6 is 36, times 1 more 6 is 216. So if you were to just simplify 27 divided by 216, you end up with 1/8, or 1 to 8 is the ratio of their volumes. Again, the ratio of their radius is 1 to 2, so since we're going to a 3-dimensional measurement, we'd end up cubing 1/2. So 1/8 makes sense for that. Number 8, we're asked for the volume of a hexagonal pyramid. So again, I'm doing 1/3 times the area of my base times my height. So we do need to find a few things here. To find the area of my base, again, I'm going to focus, it's a hexagon, I'm going to focus on this one equilateral triangle. I will need to know its height. Remember, this is a 60-60-60, so I'm chopping it into a 30-60-90, this angle down here being 60. So this length here, looking at a right triangle, where this is 4, if this is 60, this leg over here is 4√3. So to find the area of this one triangle, I'm going to do 8 times 4√3 divided by 2. Again, that's one triangle. In my hexagon, I would have 6 of those. So I'm going to put that here, 6 times 8 times 4√3 divided by 2. And my height, again, we were given that these are equilateral triangles, so this is 8 if the side length is 8. And 8 with a 17 means my height of my pyramid would have to be 15. It's one of our Pythagorean triples. So I'd end up multiplying by a height of 15. There's a lot in here. We can simplify. This 2 I can cancel out with this 6, make it a 3. This 3 and this 3 then would cancel. So I have 32 times 15 times √3. If I put that into my calculator, 32 times, so 32 times 15 times √3 puts us at 831.4 cubic units. On to number 9. We have a composite figure made up of a prism and a pyramid on top of that. We do have square prism down here, so I'm just going to find the volume of my prism and add to that the volume of my pyramid. So the prism is just going to have a base of 10 by 10, and its height is 20. So that will give us 100 times 20. So we're at 2,000 cubic units for the prism. The pyramid, remember it's a pyramid, so I'm going to do 1/3. Its base would also be 10 times 10. And its height, let's set it was 1/2 that of the prism, so half of 20 makes my height here 10. So 10 times 10 times 10 is 1,000. 1,000 divided by 3 puts me at 333.3 repeating. So rounded, we'll get an answer of 2,333.3 cubic units for this composite figure. And on to number 10, our last one, where we had 4 spheres inside a cylinder, and we wanted to find the empty space. So it should make sense that we would take the cylinder's volume and subtract the 4 spheres' volume. It gives us just the length of the cylinder, which is 20, but that means 20 divided by 4, the diameter of all these guys is 5. Just getting that again, 20 divided by the 4. So that's the diameter. Remember, our radius then of all these spheres and of the cylinder is 2.5. So to find the area of the volume of my cylinder, I'm going to do its base, which is pi, times its radius squared, and multiply by its height, which is 20. So that's my cylinder's volume. And then I have 4 spheres. And the volume of a sphere would be 4/3 times pi times my radius. We'll make sure that one's cubed. So we end up having to simplify 2.5 squared times 20. That's me at 125 pi for the cylinder. And then we have, I'm going to do my 2.5 cubed times 16 divided by 3 puts me at 83.3 repeating pi. So if I just subtract that from 125 and multiply by pi, we end up at 130.9 cubic centimeters for the empty space inside that cylinder. So that was it for the volume questions. Thank you.